This Google Earth field trip will visit 3 locations on Earth where citizens could observe a natural hazard at a local scale from the atmosphere, lithosphere, and hydrosphere. Starting with the atmosphere in California with emphasis on precipitation and rainfall. California lies above the subtropical high with westerlies winds blowing from west towards the east, which stem from the subtropical high. When traveling southeast, starting at the waterfront at the Oregon-California border, precipitation and rainfall reduces from up to 1,500 mm to 200 and even down to 0 mm. Death Valley is the hottest and driest place in North America with only 200 to 0 mm precipitation and rainfall. This is followed by the 3 deserts which show 200 to 100 mm in precipitation and rainfall. This includes the Mojave Desert, the Colorado Desert, and the Great Basin Desert. Going southeast of California, the precipitation and rainfall is at 200 to 400 mm. South California has been in a drought since a few years, and people have been advised to reduce the water usage to conserve water supply. When looking at Pasadena City College, it is clearly to see that the drought is a current threat. The severity of the drought is outweighing outer appearance. In 2003, the grass has been green. A solution would be to reduce greenhouse gases and therefore global warming and excess water usage. Now we will go to the lithosphere level of Italy and look at the volcanoes at the Campanian volcanic arc, which is an area of intense volcanic and seismic activity. This is because the African Ocean plate is subducting the Euro-Asian continental plate. Mount Etna on Sicily is the largest and active volcano in Europe. Its last eruption occurred on December 3, 2015, which produced a lot of ash plume. Mount Vesuvius is considered an active volcano as well and last erupted in 1944. It represents a great danger to the highly populated surroundings. The next volcano, and the last we are going to mention, is the volcano Stromboli, which last erupted in April 13, 2009. At every moment a new crater could open up. Or there could be an explosion without warning. No measuring instrument caught the latest eruption. Global warming enhances plate movement and heat accumulation. Here too, the rate of global warming needs to go down, and there should be no population close to the volcanoes, nor unstable houses. From here we will stop shortly in Africa and go to the hydrosphere level with focus on the Gulf of Mexico. A lot of thunderstorms are at the west coast of Africa, which also gave birth to Hurricane Katrina in 2005. Thunderstorms draw heat from the ocean surface, which is the driving mechanism that produces hurricanes. Katrina formed from a tropical wave that moved to the coast of Africa and developed into a tropical depression, a center of low atmospheric pressure. In the warm water of the eastern Atlantic, warm water rises from the ocean, then cools, forming clouds that release heat energy that fuels the storm. This sucks in more warm air, generating strong winds which shoot upwards. The storm starts turning counterclockwise and accelerates at warmer water surfaces closer to land, especially in the Gulf of Mexico. Hurricane forecasts are improving in understanding atmospheric dynamics with more satellite coverage and hurricane hunters. In 2005, the dams in New Orleans were not strong enough to resist the flooding and the strong winds from Katrina, because the cement of the dams was not meant for a hurricane in the strength of 4. And a lot of officials did not treat this catastrophe with the right emergency procedures. In high-risk areas like the Gulf of Mexico, people should not live close to the hazard zones. Global warming is also here an accelerator for catastrophes like these, and it is difficult for scientists and engineers to predict the severity.